Namaste. Welcome to Indian Knowledge Systems Primer Course for Children. In the series of lectures on astronomy, Indian astronomy specifically, we will look at Vara and Tithi in this session. Earlier, we have understood that the Indian calendrical system had a critical component called as the Pancha Anga. The word Pancha Anga is derived from Sanskrit, where Pancha means 5 and Anga meant limb or components, 5 components, 5 different organs. So, the Pancha Angam is the 5-limbed Hindu calendar. The 5 Angas that are used for keeping time are Vara, Tithi, Nakshatra, Yoga and Karana. Vara means days of the week. Tithi means a lunar day. Nakshatra means the lunar constellation and Yoga means luni-solar positional combination. That is what is Yoga. Karana means half of lunar day. So, this we have already seen in the earlier lecture. So, we will go ahead and delve deeper into the component of Vara and Tithi in this session. So, we all know generally that there are 7 days in a week. They go like Sunday, Monday, Tuesday, Wednesday, Thursday, Friday and Saturday. In the Indian calendrical system as well, we have 7 days a week. So, it goes in cycles of 7 days. 1 week has 7 days. It goes in the cycle of 7 days. So, Vara denotes this labeling system for identifying the days of a week. So, there are 7 labels that are based on the 7 celestial bodies and the labeling is assigned that way. This measure we need to understand does not have any astronomical phenomenon, which means there is no basis as to why there has to be 7 days in a week and it does not hold any astronomical phenomenon as to why the days have to be or why the cyclical sequence has to be in this way. Why should it start with a Sunday, then go on to Monday? That does not have an astronomical phenomenon. This cyclical labeling system is only for our convenience and it does not necessarily map to an astronomical phenomenon. It is important to remember that. We all know that Monday is Somavara, which is assigned to Chandra. Tuesday is Mangalavara, which is assigned to Mars. Wednesday is Budhavara, which is assigned to Mercury. Thursday is Guruvara, which is assigned to Jupiter. Friday is Shukravara, which is assigned to Venus, the planet Venus. Saturday is Shanivara, which is assigned to Saturn. And Sunday, as we all know, is Ravivara, assigned to the Sun. The labels have been based on the 7 planets and then they cyclically repeat. Please understand, we are using the word planet here very loosely. What we actually are using here is Graha. Graha we understood is that object or that celestial entity which has a special motion. That's what is Graha. We saw that definition in the previous lecture. So, we also should understand that the naming or the design of the Vara itself is not based on any astronomical event or phenomenon, but it is designed only for our convenience. A 7-day week, the reason for choosing it or why it has to be of the length of 7 days do not have any astronomical significance at all. But the label helps us to look at time and days of the week in a very cyclical manner so that it helps us organize our lives easily. That's the whole rationale. Very interestingly, the calendrical item called the Vara, this set of 7 days and the naming is used by all the calendars of the world. In fact, they maintain the same naming sequence. It starts with Sunday, goes on to Monday, Tuesday and then ends with the Saturday. This naming sequence is very, very congruential. It's very similar. It's in fact exact. And they comprise this week. This shows that the calendrical unit has spread out. It should have definitely spread out across the world from one source and it has been adopted it has been adapted as well across all the calendars around the world. Although researchers have not been successful in determining the exact source or the origin of the Vara with any certainty. But it is clear that there has been some exchange of ideas by different ancient cultures, as well as even in the lines of calendrical planning and design. Such deep knowledge exchanges should have definitely happened across the different ancient cultures that existed at that time. That's something that we can infer and understand. The names of the 7 days of the week, interestingly, are not found in the Vedas. There is no reference to the use of, the Vara dinas even in Mahabharata. Very recently, in only one verse of Vedanga Jyotisha, a recension in the Atharva Veda, the names of sun, moon and the 5 planets occur, and they also occur in the same order as that of the Vara dinas. Then the names have been mentioned in the same order like how it is in the present day week, and these have also been mentioned as the lords or the devatas of that particular day. This is the earliest reference we find, especially with respect to the 7 grahas. We keep switching between grahas and planet. I am reiterating again. Grahas are those set of celestial bodies which have special movement from the observer point of view. They are loosely translated in English to planets. It is also interesting to note that determining the days of the old traditional Hindu festival, they are not bound with Varas at all. There is no significance of Vara and Hindu festival, but there is a strong alignment, or they are tightly coupled with the lunar positioning, which is called as a Tithi, which we will see shortly in this session. So, lunar and solar positions, they come into play, but the Vara labeling is never mentioned for determining a Hindu festival, a traditional Hindu festival. That said, there definitely is some rationale to this Vara sequence. It's not completely a random order. There is some rationale to it. Let us try to explore how it came into being. So, in the modern day, we know that one day is a sequence of 24 hours and each hour is accounted for 60 minutes. Earlier in the Indian tradition, they used to take a day as to be made of 60 ghatis, which mean the entire day, which is still 24 hours, would be divided, or it will have 24 divisions, but the duration of the entire day is same as now, but each gati will be 1/60th of the current duration, which makes it to 1 gati's length, or the duration becomes as 24 minutes. And these Vara dinas are named based on the graha of the first ghati that comes up on a day. What does that even mean? We will try to understand slowly. So, we have now understood that a week is going to have 7 days. We are using certain labels for identifying each of this day, and this comes in a cyclical sequence. This necessarily does not have an astronomical event or phenomenon attached to it. It is more for our practical convenience. This we have understood. We also saw that the naming is very similar across different cultures. Now we are trying to understand, there is, especially in the Indian traditional calendrical system, there is some rationale or logic behind how these Vara dinas were named in sequence. There is no celestial, there is no astronomical event attached to it, but there is a logic behind keeping this Vara dinas in a specific sequence that we are trying to understand using the Gati system. We said that the duration of the day is as same as the current day, which is 24 hours, but this duration is split into 60 ghatis. So, one day is considered to have 60 ghatis, and thus each ghati will span for 24 minutes because it is 1/60th of the duration of one day. So, it is 24 minutes. One ghati is 24 minutes. Now, what are we going to do is, we will order these Varadinas. The Varadina naming will happen by ordering the respective grahas in the increasing order of their revolutionary periodicity. We will see that in the next slide. So, this is how in increasing order we are writing. If you look at the grahas, the right side of the table is the grahas order assignment in the Gati system based on their revolutionary period. Okay. So, it starts with moon. Moon of course has a very small revolutionary period of 27.33 days. While Mercury, it takes about 88 days, and Venus takes about 225 days. Sun, basically Sun is from an observer point of view, so it takes about 365.25 days. So, we are going around the Sun and we are watching the Sun situating ourselves on Earth, and that is how we see that from one Mesha Lagna to another Mesha Lagna, when it traverses from one Mesha Lagna to again to the same Mesha Lagna in the Ba Chakra, it takes about 365 days. So, that period is accounted as the revolutionary period of the Sun. Well, what exactly is happening is, we are revolving around the Sun because since we are situated ourselves as the observer, this is how the experience is for us. Mars, for example, takes about 687 days, roughly about 1.8 years to complete one full revolution, and Jupiter takes about 12 years. Saturn takes about 29.5 years. That big is the revolutionary periodicity. So, this is ordered in the increasing order of revolutionary periodicity, and then once we have it like this, there is an arbitrary assignment of each Gati. For example, let's take one day. Now we have to name the day. We will name the day as Monday or Somavara. So, the first Gati will belong to moon. So, how many Gatis are there in a day? 60 Gatis. So, first Gati is moon, thus it becomes Somavara. Now, we need to know what is the next day should be named as. For that, we will traverse through the Gati system. So, then we will assign the second Gati of the Monday to Mercury. Third set of 24 minutes will be assigned to Venus. And so, it goes on and on and on in this particular order of revolutionary periodicity. Then what happens? So, when we keep on going like this, 7 8s are 56. We would be able to assign 56 Gatis comfortably in this order. So, 1 to 7 is named here, right? So, first Gati on a Monday will belong to Somavara, will belong to moon. Second Gati, second 24 is Mercury, third 24 is Venus, fourth 24 is Sun, fifth 24 is Mars, sixth 24 minutes is Jupiter, seventh 24 minutes is Saturn. So, 7 parts of the 60 parts is over. So, we keep traversing like this. So, there are 8 Gati assignments we are doing. 7 Gati assignments we are doing. So, 7 8s are 56. We would be able to finish 56 Gati assignments. So, 56th Gati, 56th 24 minute slot will be assigned to Saturn on a Monday. Then comes 57. 57 will be assigned to moon. 58 will be assigned to Mercury. 59 will be assigned to Venus. 60 will be assigned to Sun. 61 means it is a new day. This new day, the first Gati will get assigned to Mars. This is the cyclical Gati system for ordering the days. So, if it gets assigned to Mars, what does that mean? The first day started with Somavara, first Gati is to moon. The next day becomes Tuesday, which is Mangalavara, and the first Gati of the Tuesday gets assigned to Mars automatically through this cyclical system. I hope I am making sense. Similarly, if you start assigning from Mars, if you start calculating 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, go on and on, the 56th Gati on a Tuesday will get assigned to Sun, Again go forward. 57 will be Mars, 58 will be Jupiter, 59 will be Saturn, 60 will be Moon. So Tuesday is also over. 60 gatis are over. 61, which will be the next day, the first gati of the next new day, will get assigned to Mercury, which is Budavara. Okay, am I making sense? That is how it came on to being sorry, Somavara, Mangalavara, Budavara, Guruvara, Shukravara, Shanivara and Ravivara. That is how. So, we could see that there is some logic behind the ordering of the Varadinas. We do not have any astronomical significance per se. Let us look at another so this we have covered. Vara component of the Panchanga we have covered. Now we will move on to Tithi. This is a very, very important concept. We will try to understand, and it has a strong astronomical phenomenon associated with it, unlike Vara. Tithi is considered to be a lunar day. Tithi is also very central to the lunar calendrical system. Tithi is defined as the time it takes for the longitudinal angle between the moon and the sun to increase precisely by 12 degrees and its integral multiples. What are we trying to say? Tithi is the time taken by, or rather, Tithi is the time taken for the longitudinal angle between the sun and the moon to increase precisely by 12 degrees and its integral multiples. For example, multiples of 12 in the sense 12, 24, 36 and so on. So, the angular difference in their longitudes of the sun and the moon. What does this even mean? We will try to understand. So, we will try to find where exactly in the bar chakra, in the 360 degree position, sun is placed. That is considered to be the longitudinal angle of the sun or longitude of the sun. Similarly, where exactly is the moon placed with respect to the ecliptic or the bar chakra? That is considered as the longitudinal angle or longitude of the moon. So, the difference between these two is taken for Tithi calculation. For example, let us assume that the sun is roughly about in 250 degrees and the moon is in 260 degrees. So, the longitudinal angular distance between them is roughly of 10 degrees. That is how we go on to calculate. So, every lunar day we are saying that it is going to be a 12 degree movement of moon with respect to the sun. That is important. With respect to sun, this is where the luni-solar aspects match. So, with respect to the sun, we are going to calculate a lunar day as the amount of time the moon specifically takes to traverse through 12 degrees with respect to the sun. And there are 30 such tithis or lunar days in a lunar month. What is a lunar month? A lunar month is more of a the one full synodic period is a lunar month, meaning it will have 15 days of Shukla Paksha and 15 days of Krishna Paksha, waxing and waning. So, the waxing period is called as the Shukla Paksha and waning period is called as the Krishna Paksha. This we will also try to understand using a small simulation. Now,
in this simulation, let us try to learn the relative position of moon with respect to the sun, how it moves, how our tithi is formed, how do lunar months happen. Let us say this was the 6th lunar day. What it is, what does it mean? We will see later. However, one day in the sky, you could see the sun here and let us say you could see moon here. Have you seen this? Some days you can see the moon even during the day. But you might not have observed carefully how the moon's position moves day by day. Now through this simulation, we will try to understand that. Let's say I run the time and I make it go one day further and come back to the same 2 p.m. the next day. From the same place I am observing. Did you observe? The separation between the moon and the sun changed. I go further. The separation between the moon and the sun changed. This angular separation, right? It's far away. Same 2 p.m. Now again, 2 p.m. it's further away. Another day, it's further away. It's exact same 2 p.m. It's further away. Let me switch a few hours. Now, I'm going to go 4 p.m. of the next day. The moon is getting further away and away and away. You see, sun is here, but the moon is yet to rise. Let's say I shift by 1 more hour. So 5 p.m. If it was 2 p.m., the sun would not have risen, right? 3 p.m., the moon is not there. If it was 2 p.m., the moon would not have risen. If it was 3 p.m., the moon would not have still risen. But now, around 4 p.m., the moon is slowly rising. And around 5 p.m., the moon is up there. But if I go the next day, what do you think will happen? The moon will further be away from the sun. Same 5 p.m., the moon is just rising. Same 5 p.m., you can't even see the moon now. If the sun sets, only the moon will rise, and that would be a full moon day. What happens the next day? The angular separation between the sun and moon will start to slowly decrease. How do we see that? Let's come to again morning. Let's observe the morning. While the sun is rising, the moon will be setting. Slowly, it's coming closer and closer to the sun. Earlier, it was going farther away from the sun every instant. The same moment of the day, you can see the moon coming closer and closer to the sun. So, the angular separation keeps decreasing. Now, if I was in mid-noon, you see, the moon is very close to the sun. Next day, it's a little away. Next, further away. Then a little further away. So, every day, the angular separation between the sun and the moon, if you observe at the very same instant, you would see that they will be slowly increasing by at an average of 12 degrees per day. The angular difference between the sun and the moon will keep increasing day by day. Now, why is this happening? And how do we keep track of the lunar month? Keeping track of the lunar month, we need lunar days. In the Indian calendrical system, we divide the lunar month into 2 fortnights. We shall see this through a different simulation. We all know that during a new moon day, the sun and the moon are together. However, not every time will the moon eclipse the sun, because the orbit of the moon will be tilted with respect to the orbit of the sun. Now, this is an observer on the earth, and the earth is here. This is the moon's orbit, and far away is the sun here. The top view here presents the view for the observer on the earth. Slowly observe what's happening when I shift one day. When I shift one day, you see, now for the observer on the earth, the sun and the moon, which is very mildly only visible, is a little away. Now it's further away, right, from the sun. Why has it happened? Here, as you can see, the moon is moving in its path around the earth. As it increasingly happens on the earth, we will observe that the angular separation between the sun and the moon keeps changing and keeps increasing. As you know, we started from a new moon day, right? We started from a new moon day, and slowly what happens? slowly you will see that the angular separation between the sun and the moon, as the moon revolves around the earth, the angular separation between the sun and the moon keeps increasing. And the day and night is caused because of the earth's rotation. We turn around, come and see, we witness the sun and the moon, then it becomes our night. Right? Slowly the angular separation keeps changing. Isn't that very, very fascinating? So this period where from new moon day, which is called Amavasya in the Indian tradition, to Purnima, which is the full moon day in the Indian tradition, where the moon will be visible only in the night and not in the day. And it will rise when the sun has set. The sun is setting, the moon would rise and it will be visible. This is called a Purnima or a full moon day. So the period from the new moon day to the full moon day is called, you would have all studied in your school as the waxing period. In the Indian tradition, it's called the Shukla Paksha. And slowly the moon starts fading away day by day. You will see that little portion of the moon becomes dark, 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 all the way from Purnima to Amavasya. This is called Krishna Paksha, where you again experience a new moon day. So you may wonder, see, the sun is here, the moon is here. Shouldn't an eclipse be happening? It won't happen because the angular separation between sun and moon is 0, but this orbit of the moon, right? Orbit of the moon is tilted with respect to our, plane of our orbit, right? So once in a while, when the orbit of the moon and our planetary orbit intersect, then those times when the moon is there, an eclipse can happen. Similarly, when the earth is there at some point in time, we can eclipse the sun for the moon also. So that is about eclipses. But here we must appreciate that every day the angular separation between the sun and the moon keeps increasing. By how many degrees? By approximately 12 degrees every day. And so how many degrees are there in a circle? There are 360 degrees. If you divide 360 by 12, you will get 30. So we look at 30 lunar days or lunar tithis. So a lunar day is not same as the solar day of 24 hours. A lunar day is basically whenever the moon grows in increments of 12 degrees, then 24 degrees, then 36 degrees, all multiples of 12, all the way till 180 for Purnima, then from 180 to 360, as it grows in multiples of 12, each time the angular separation between the sun and the moon increases in multiples of 12, then a tithi is noted. Thank you.
As we saw in the simulation, every day the angular separation between the sun and the moon, they keep increasing. In the Shukla Paksha, which is the waxing period, which is from Amavasya to Purnima, this period from new moon to a full moon day is called as Shukla Paksha. Amavasya to Purnima is new moon to full moon. This is the period of Shukla Paksha or the waxing period, waxing fortnight. So what happens? There are the tithis of, we will try to name the tithis once: Pratama, Dvitiya, Tritiya, Chaturthi, Panchami, Shashti, Saptami, Ashtami, Navami, Dashami, Ekadashi, Dvadashi, Trayodashi, Chaturdashi, ending with Purnima. After Purnima starts the Krishna Paksha or the waning phase, which means from full moon to new moon, another 15 days, another one fortnight. The same set of tithis will repeat, ending with Amavasya. So this part, new moon to full moon is called as Shukla Paksha, the waxing phase, and full moon to new moon is called as Krishna Paksha or the waning phase. So among these 30 days, we have also marked the angular separation. Across each of the Tithi with respect to the Paksha, we have marked the angular separation. So, because each will be a 12-degree movement, we have already seen that one Tithi is going to be 12 degree, that is fixed. So, each Tithi will vary once the 12-degree length is traversed by the moon with respect to the sun. Now, for example, if the angular separation between the sun and the moon was 280 degrees, what will be the Tithi now? It will be Krishna Paksha Navami. You can see it on this side of the table. Similarly, now if the angular distance between the moon and the sun is roughly about 40 degrees, then it will be Shukla Paksha Chaturthi. Do you understand? This is how we will try to calculate the Tithi. So, Tithi calculation we have clearly seen. We have ordered each of the Tithi, each of the days, we have named them. We have ordered it based on the 12-degree difference. We will try to find the angular distance based on the Ba Chakra with respect to the Rashi, Rashi calculation. We will try to find the longitudinal positions of sun and moon, find the difference. This difference, wherever we can place it in the previous table that we saw here, that is how the Tithi will get calculated. Okay. Now, we have seen the calculation of the Tithi very clearly. Every day, when you look at the Panchanga, you can even see the calendrical sheets that have been printed in India that will carry the Tithi and the Nakshatra also in them as well. So, Panchanga, if you see daily, it's an Indian calendrical system, right? Well sorted, well ordered Indian calendrical system. So, if you see, each Dina will have a clear mapping of the Tithi that comes up in that Dina and the Nakshatra as well. So, this is what Tithi is, this is how we calculate, we have understood. Let us try to understand some interesting facts with respect to Tithi. See, the average duration of a Tithi is not so uniform like we think, and it will definitely be less than a day. Why so? Now only we saw each Tithi will correspond to a lunar day, 30 days will come, there will be 30 Tithis, we divided it into 2 Pakshas, Krishna and Shukla. Now what is this new confusion of each Tithi will be less than a day? Why does that happen? Let us try to understand. We need to understand a term called a synodic period, the mean synodic period of a moon. We will try to understand the word per se, what is synodic period. Synodic period means for one astronomical phenomenon to happen again, the time taken between these two. So, now there has been a new moon. For the new moon to come over again, the time period between this is called a synodic period. It's also with respect to the mean solar days. Okay. So, then there is one more, a term called as a sidereal period. Sidereal period is usually where the celestial object will come back to its own position with respect to the stars, meaning with respect to the ecliptic or with respect to the stars. This particular celestial object would do whatever it has to do, because it's a graha, no, it will have that special motion but come back to the same place. That's called a sidereal period. So, the first one is with respect to a phenomenon, an astronomical phenomenon to repeat itself again, it's a synodic period. But a sidereal period is for the celestial body to come back to its own position with respect to that particular stars. We have also understood that the mean synodic period between, let us say, from one Amavasya to another Amavasya, irrespective of where the moon is, where it is in the Ba Chakra or the ecliptic, we are able to see that it is 29.5 days. But whereas we have 30 Tithis. So, if you see, if you try to divide, definitely one Tithi measurement will be less than 1 day, no? It will be roughly about 0.98 of a day, which is definitely less than 1 day. So, these many days it will take to complete the 30 Tithis. So, to complete one Tithi, 29.5 divided by 30, that is what we use to measure how long will it take to complete one Tithi, which will be roughly about 23 hours and 37.5 minutes. That is what it will take to complete a Tithi. Though we say this, it can vary quite a bit as well. You know why? Because the orbits we have clearly seen, they are not circular for things to be so uniform. They are elliptical. So there will be some places where the Tithi will go faster and there will be some places where the Tithi will be like slowly spaced out. So the Earth's orbit around the Sun is not going to be in perfect circle. So the orbit of the Moon around the Earth is also not a perfect circle. So because both of these are elliptical, this happens even in Shaura Masa. What is Shaura Masa? The Masa of the Sun. In the solar month, we saw variations in the periodicity. We saw how it will vary. We saw, no? Mesha Masa, Falguna Masa, all of these Masas we saw based on the Rashi. So, we saw that the days of that solar month were also varying. It was not specifically 30 days. Some were 28, some were 31 and things like that. So, this will vary. So, it will definitely take different time period to be in different Rashi, the Sun. This is what we saw in Shaura Masha. Sometimes, similar thing happens for the Moon as well. So, when the Moon is very closer to the Earth, the transit will be very faster. So, Tithi will move very fast. But if it is a little far, it will move little slowly. It will be spaced out. So, when the transit is very faster, it will complete more angular distance. What happens when it moves faster? It will complete a lot of angular distance in a very less time. So, it can complete up to 15 degree 23 minutes in a matter of day. Sometimes it can be very slow as well, such as it will be able to complete only 11 degree 46 minutes in one day. So, this is the difference between angular completion, angular distance completion. So, an average of somewhere between 30 degree 20 minutes is seen as the lunar motion per day with respect to the Sun. So, the average duration of the Tithi we already saw is about 23 hours and 37 minutes, 37 and a half minutes. This also will hugely vary based on this, because someday a Tithi can be as small as 20 hours. Why? The Moon would have traversed faster. But someday it can be as large as 26 hours 47 minutes as well. That is the highest it can traverse, which is roughly about 27 hours. All this variation, all of this is everything in the sky. All of this is very dynamic. It is not like any arithmetic calendar. This is a very dynamical system, because the whole of the Tithi calculation is based on the astronomical phenomenon of revolution and movement of Sun with respect to revolution and movement of Moon with respect to Sun from the observer's point of view of the Earth. So, they had given calculations and solutions for arriving at the position of the Moon very accurately, but at the same time this is a dynamic calculation. So, the synodic period also we saw that it is roughly about 29 and a half days. That also will vary. So, all of this is very dynamic with respect to space. So, Shaya Tithi, if you see the day of the Indian calendar is usually from sunrise to sunrise. So, when we say something as a day, it is not like the strike of midnight. No, we do not calculate like that. In the Indian calendrical system, it is usually from sunrise to sunrise. The period from the first sunrise to the next sunrise is considered as one day. Therefore, in counting the days of the lunar month, the Tithi that is prevalent during this time of sunrise is taken as the Tithi of the day. For example, the Paksha is calculated anyway. We know whether it is Krishna Paksha or Shukla Paksha based on the phases of the moon. To identify which day it is in the lunar month, we will be marking the Tithi at the time of sunrise of that particular day. Also, each of the day will be numbered. The number is the ordinal number of the Tithi. What does this mean? For example, if during sunrise of today it is Tritiya, if the Tithi is that of Tritiya, for example, if during the sunrise of today the Tithi was that of Panchami, and we also know whether it is Shukla Paksha or Krishna Paksha, we will calculate that. Then Panchami is the 5th Tithi. So, that the ordinal number will be 5. So, that particular day will be marked as the 5th day. Okay. So, this is how the days are numbered in the lunar month. But the time in a day, which also includes the night, because sunrise to sunrise also includes the night, when the Tithi ends and the next Tithi starts, they are not the same. Why? We clearly saw a Tithi will span somewhere between as small as 20 hours, roughly 20 hours, which is exactly 19 hours 59 minutes. It can be as small as that to the duration of 26 hours 47 minutes, which is roughly 27 hours. So, the average duration of one Tithi can be seen only as 23 hours 37 and a half minutes. That is the average duration, because it can span, one Tithi can span anywhere between 20 hours to 27 hours. So, the average duration comes between 23 hours 37 and a half minutes. So, you can clearly see that there is a fair chance that from one sunrise to another sunrise, it need not be the same Tithi. For example, if today during Panchami, for example, if today during sunrise, if it was the start of the Panchami Tithi, it might have gotten over the same day itself. Let us say it is about, we are traversing through the 5th hour of the Panchami Tithi during the sunrise. So, already 4 hours are over, and that particular Tithi can go on for, let's say, 22 hours or something. Then 4 hours are over. So, there is only 18 hours remaining. So, the next day morning, roughly about 1 am or so, Panchami Tithi would have gotten over. So, the next day during sunrise, it would have become as Sashti. Do you understand? If the Panchami Tithi spans for roughly 22 hours. But what happens if a Tithi spans only for 20 hours, and assume that the Tithi starts at 7 am, which is slightly after sunrise. But by 20 hours, it would have gotten over. The next sunrise, it would not even see. That Tithi would not even see the next sunrise. So, if a Tithi starts and ends between two sunrises, okay, between two sunrises, if a Tithi starts and ends, then such a Tithi is called as Shaya Tithi. What is it called? Shaya Tithi. And the day would never be counted based on the Tithi's ordinal number. For example, if today morning we are at the 21st hour of Panchami during sunrise, then Sashti starts, 20 hour it gets over, the next day morning it will be Saptami. So, the days will be numbered as 5 and then 7. There will be no 6th lunar day at all. It is just a numbering system. We will understand why we are using this in another concept coming later in the lecture. Okay. So, this is how the ordinal number also gets missed out. The Tithi, when the Tithi becomes a Shaya Tithi, then the days are never numbered with that particular ordinal of the Tithi. Okay. So, this is with respect to Shaya Tithi. But we also saw a Tithi can span as long as approximately 27 hours. So, what does that mean? During the start of sunrise of today, it can start, the Tithi can start during the start of the sunrise of today, and it can go on till the next day. That is still a possibility. So, now we will have 2 days with the same Tithi, right? We will have 2 days with the same Tithi. This is called as Adhika Tithi or Ahoratra Tithi. What is it called? Adhika Tithi or Ahoratra Tithi, meaning one Tithi has seen 2 consecutive sunrises. So 2 days will be having the same Tithi and they will also be numbered like that. If you take up Ashtami, it will be 8, 8 and then 9 and so on, however it goes. Okay, am I making sense? So this for Adhika Tithi we clearly saw that the Tithi was extending on both sides of the civil day. A civil day which is normally considered as the 24-hour cycle, midnight to midnight, that is a civil day. So, it will be extending on 2 civil days. That Tithi is called as Adhika Tithi or Ahoratra Tithi, in which case for Adhika Tithi, the sequence of the days will be counted twice. 1, 2, 3. For example, if Adhika Tithi is during Chaturthi, it will be 4, 4, 5 and so on. Okay. Now, again, we take the case of 27 hours, roughly 26 hours 59 minutes Tithi. If a Tithi spans for 26 hours and 59 minutes, then what will happen? It can even spill over on the third civil day. How is it so? We will see. So, we have seen 2 cases wherein the Tithi length, the duration of the Tithi is so small that it never gets to see any sunrise between 2 consecutive civil days. That Tithi is called as a Shaya Tithi, and that ordinal number will never be included in the sequence of the days of that particular lunar month. This we have seen. We also saw what is an Adhika Tithi, wherein the Tithi will span across 2 civil days. It will see 2 sunrises. That is called as an Adhika Tithi, and the sequence will be named, sequence of the days will hold the ordinal number of that Tithi in that particular lunar month. So, this too we have seen. If a Tithi is as long as the maximum duration possible, which is roughly about 27 hours or 26 hours 59 minutes to be precise, if it spans across like that, then there is a possibility that the Tithi can insert itself into the last hour of a civil day. For example, today from 11 to 12 in the midnight, it can insert, the Tithi can start. So, it has touched today, it has spanned in today. By the day I mean the civil day. Today's civil day gets counted as that Tithi. The next day also it will span, because full 1 hour is over, then there will be 24-hour cycle for tomorrow. So, 25 hours are over, and then there is 2 more hours. So, it will get added up, or it will flow into the third day as well. Do you understand what I am saying? The days that I am talking about here is the civil day. So, it will span across 3 civil days, the 24-hour cycle that we follow generally. Such a Tithi, such a spillover, this also happens once in a while. Such a spillover, or when if the Tithi gets to touch 3 different days, it is called as Tridina Sprik. Tridina Sprik. It is called Tridina Sprik. So, such interesting concepts and useful astronomical phenomena have all been carefully calculated, observed, understood, analyzed and been made useful in the, have been made a part of the Indian calendrical system. So, let us go on. We have now covered 2 components in the Panchangas. So, we will go on to cover the other 3 components in the next lecture. Thank you.